H2N plus 2, right? So
Yes,
when
ma'am.
you remove, suppose if I take methane, this is your alkene, example of alkene, methane, right? And if you replace this hydrogen, the basically this is a substitution reaction. So when you replace this hydrogen, remove this hydrogen and replace this hydrogen from the halogen group. Okay, so when you remove the hydrogen from here and attach one halogen to this carbon, so this compound, this is known as haloalkane. Okay, so basically what is haloalkane? So it's a substituted product of alkane by the halogen. Okay, so basically how we obtain the haloalkene? So it's obtained by the replacement of hydrogen atom of an alkane by a halogen group or halogen atom, right? So this is known as haloalkane. Clear?
Yes, ma'am.
Similarly, haloarenes. So what is haloarenes? So halogen, again the halo word, halo means halogen, and what is arenes? So arene basically is known as aromatic. Aromatic type of compound के लिए we just use arene. And what is aromatic type of compound? So just like a benzene, when you see the conjugated pi system, means the alternate double and single. See, this is a double bond, then this is a single bond, then double bond, then single bond, then double bond. So this is a aromatic system. This type of system is known as aromatic system, where you will see the alternate double and single system. Means that type of system is known as conjugated system. Is it clear, Aneesha?
Yes,
Arenes.
ma'am.
या सो इसके लिए हम क्या यूज करते हैं बेसिकली एरोमेटिक कंपाउंड्स के लिए वी जस्ट यूज एरीन्स और अराइल. Okay, so arenes is also known as aryl halide, okay, or haloalkanes is known as alkyl halide. Okay, this is your aryl halide, and haloalkane is also known as alkyl. Okay, alkyl for the alkane group and halide, the halogen group. Alkyl halide or haloalkanes both are same, and haloarenes and aryl halide both are same. Clear?
Yes, ma'am.
Similarly, when you take a benzene ring, aromatic, any aromatic, so this is an aromatic type of, so you can see it to this carbon, to all the carbons, there is a hydrogen group. One hydrogen group is present, right? So when you replace this hydrogen by halogen group, any halogen group, when you remove this hydrogen and you attach the halogen group over here, or halogen group could be your fluorine, chlorine, bromine, or iodine. Yeah. So this is known as your haloarene, haloarenes. Okay, or aryl halide. Yeah. So when the halogen group is attached to the benzene ring, to the aromatic ring, so it is known as haloarene or aryl halide. Clear?
Yes, ma'am.
Okay. Next, let's see the classification of haloarenes and haloalkenes. How the haloalkenes and haloarenes are classified. Yeah. So on the basis of the number of halogen atom, so haloalkane and haloarenes are classified in various compounds, you can say, or you can say only three types. Three types and many types भी हो सकते हैं. Basically, there are three types of haloalkanes and haloarenes on the basis of the number of halogen atoms. First one, when only one halogen atom is present. Only one halogen atom is there in the alkane. You can say alkane. Suppose this is your CH3. This is your CH3, CH2, right? And here chlorine. If I attach the chlorine over here, so you can see only one chlorine group. Chlorine is attached to the carbon. Only one chlorine is there. So we call it as a monohaloalkane or monoalkyl halide. Yeah. So mono means mono halogen, only one halogen atom is present. Mono word इसके लिए हम use करते हैं for one. Okay, so if one halogen atom is there, then we call it as a mono haloalkane. Okay, and if it is a haloarene, suppose, yeah, benzene ring is there, and if I attach chlorine over here, so you can see only one chlorine is attached, right? So you can see only one chlorine is attached to this ring, right? This aromatic ring. So this is known as monohaloarenes. Clear, Aneesha? Monohaloarenes.
Yes, ma'am.
Yeah. Similarly, when the two halogen atom is present, if two halogen atom is present, then we call it as a dihaloalkane and dihaloarenes. Dihaloarenes. Okay, just remember for the arenes, you should first check it once whether it's the structure, is it benzene or not? Is it aromatic ring or not? Okay, so if to the aromatic ring, if two halogen groups, suppose here fluorine is attached and here fluorine is attached, or fluorine be attached हो सकता है, right? So same halogen group could be there, or sometimes there will be a different halogen group. So if two halogen groups are attached to the benzene ring, to the aromatic system, then we call it as a dihaloarene. We call it as a dihaloarene. Clear, Aneesha?
Yes, ma'am.
Similarly, when the three halogen atom is there, so it will be called as a trihaloalkene or trihaloarenes. Yeah, so it's very simple. And yeah, because sometimes we just have another classification also, polyhaloalkene. Polyhaloalkene or polyhaloarenes. So poly word is used for the many, right? If the halogen group, halogen atom is more than one, so we call it as a poly, right? So polyhaloalkene or polyhaloarenes. Yeah, see, this question. In this question, we have to classify the following on the basis of the number of halogen atoms, right? So tell me, Aneesha, first one, which type of which classification it is?
Monohaloalkane.
Yeah, it's a monohaloalkane. The second one,
Dihaloarene.
yeah, it's a dihaloarenes. Third one,
Trihaloalkane.
yeah, yeah, halo word you can write. Yeah, similarly, this is your aliphatic ring, right? Aliphatic structure. So again, this is your dihaloalkane. Fifth one, trihaloalkane. And what
Yes,
about the
ma'am.
sixth one? Sixth one?
Dihaloarene.
Yeah, it's arene. Very good. Ah, okay. Now it's very important. So monohaloalkanes are basically divided into two groups, two types. First one, when the halogen is attached to sp3 hybridized carbon, right? sp3 hybridized carbon. You know how to find the hybridization state?
Yes, ma'am.
Yeah, that's good. Yeah, so when the halogen group is attached to sp3 hybridized carbon, so we have three types. We have the halides are of three types. First one is your alkyl halide. Second is your allylic type of halide, or you can say allylic haloalkene. And the third one is your benzylic halide. Okay, we will see in details. Now the second one is monohaloalkane, where the halogen group is attached to sp2 hybridized carbon. Means carbon-carbon double bond you will see. Carbon-carbon double bond. So on the basis of that, there are two types of halide. First one is your vinylic halide, and the second one is your arylic halide. Aryl halide, arylic halide. Yeah. Okay, see the first type. See this type. When the halogen group is attached to the sp3 hybridized carbon, right? So alkyl halide, see this alkyl halide. So alkyl halide, the other name of alkyl halide is haloalkene, right? Yeah. So see the example. So in this case, you will see the halogen group will be attached to directly to the sp3 hybridized carbon, right? So see example number one. So the fluorine is attached to this carbon and check the hybridization state. Check the
sp.
hybridization state. Yeah. So it's sp3, right? So this is, and tell me what is the degree of this carbon, whether it's a primary, secondary, or tertiary. Primary halide, secondary, or tertiary.
Primary.
Yeah, it's primary. It's a primary type of alkyl halide. See the second one. See the bromine is attached to this carbon, right? So again, this carbon is sp3 hybridized. So again, this is an example of alkyl halide. And what is the degree? So you can see this is your, what is the degree of this? This is your
Second.
secondary. Yeah, it's a secondary type of alkyl. Third one, again the, see,
Secondary.
yeah, yeah, this carbon is
sp3.
attached to, yeah, it's sp3. This carbon is sp3, right? So just remember this. Okay, if the carbon, if there is a alkane group, carbon, between the carbon, there is a single bond. So again, it's a sp3 hybridization. Carbon double bond sp2 and carbon triple bond, it's sp hybridization. Yeah. Now see
Yes.
the fourth one. The bromine is attached to this carbon. And what is the hybridization state? Again, this is sp3. But what is the degree? 3 degree. Yeah, it's tertiary. Is the
Yes.
tertiary, right? So these are the examples of alkyl halide where the halogen group is directly attached to sp3 hybridized carbon. Now the second type is allylic haloalkene or allylic halide. You can say allylic halide or haloalkene, both are same. In this case, halogen group is attached, halogen atom is connected to sp3 carbon, right? And which is further connected to sp2 hybridized carbon. Yeah, further you have to check, right? See, allylic haloalkane is that type of alkane, that type of halide, you can say, that type of halide where the halogen group is first directly attached to sp3 hybridized carbon, but that sp3 hybridized carbon is attached further to the sp2, right? So you have to check further, that is sp2 hybridization is there or not. So that's the case of allylic. That's the case of allylic halide. It's very important. Right? See the example. See this in this first example, the bromine atom is attached to this carbon, right? And this carbon is sp3 hybridized, right? And further, this sp3 hybridized carbon is attached to carbon-carbon double bond, which is sp2 hybridized carbon, right? So this is your allylic halide, allylic halide, and we call this carbon as a allylic carbon. Second example, see the chlorine is attached to this carbon, right? This carbon is sp3, right? Now again, this sp3 is attached to this carbon-carbon double bond, and this carbon is sp2 hybridized. Yeah, so this is your allylic halide. Clear, Aneesha?
Yes, ma'am.
Third one, benzylic type of halide. Now, in benzylic type of halide, because benzylic word, there is a benzylic word. So again, benzene से कुछ relate होगा. So that's why benzylic word is used. So halogen is connected to, see, in this type of halide, halogen is first connected to sp3 hybridized carbon, and this sp3 hybridized carbon is directly attached to the benzene ring, the carbon of the benzene ring. Okay, so this is your benzylic halide. This is your benzylic halide. Clear?
Yes, ma'am.
Yeah. Okay, you can write down the example of this. Okay, suppose there is a benzene ring. Okay, the chlorine is attached to this, and further, this is the next. Yeah, see this type. When the second type is when the halogen atom is attached to sp2 hybridized carbon. Okay, so first is your benzylic halide. Sorry, vinylic halide. When the halogen is directly attached to sp2 hybridized carbon. Okay, So this is known as your vinylic halide. Okay. See example. In this case, you will see halogen is directly connected to the carbon-carbon double bond. Okay. First example, see the bromine is attached to this carbon, right? And this carbon is your sp2 hybridized, right? So carbon-carbon double bond, you will see. So this type of bond, this type of halide is known as vinylic halide. Clear, Aneesha?
Yes, ma'am.
Second, arylic halide. Yeah, so already we have discussed what is aryl halide or what is haloarene. Okay, haloarene and aryl halide both are same, right? So aryl halide, when the halogen is directly attached to the benzene, when the halogen is directly attached to the benzene ring, so it is known as aryl halide or haloarenes. For example, suppose there is a benzene ring and here I just attach the chlorine. Okay, suppose there is a benzene ring. Again, here I attach the bromine, etc. Okay, so this is known as your aryl halide. When the halogen is directly attached to the sp2 hybridized carbon of benzene ring, Now see, there is a difference between the arylic halide or the benzylic halide. Don't be confused in these two. When I say benzylic halide, it means that the halogen is attached first to the sp2 hybridized carbon, right? CH2, and this sp2 hybridized carbon is attached to the carbon, to the to the benzene ring, right? To the benzene ring. So this is your benzylic halide. This is your benzylic halide. When the chlorine is attached to the sp3 hybridized carbon, right? And further this sp3 hybridized carbon is attached to the benzene ring. इसे हम क्या कहते हैं benzylic halide. But when I say aryl halide, so it means that the halogen group, halogen atom is directly attached to the carbon of the benzene ring. Okay, so that's a major difference between this is your aryl halide and benzyl halide. Yeah, clear, Aneesha?
Yes, ma'am.
Now you can write down from the starting. Yeah, now you can make notes.
Ma'am, in the beginning, when I joined the classes for the first time, you had introduced me to this chapter till benzylic halide, and then after
Okay,
that, you started with bridge course.
oh, okay,
Yes, ma'am.
okay. आपको starting में बताना चाहिए, then I should have start from that. Okay, so you have written that.
Yes, ma'am, till benzylic halide.
Yeah, okay. Till benzylic halide. And this also aryl halide.
Yes, ma'am.
Okay, no issue. So we can continue. So tell me, we have discussed this question.
No, ma'am, we had stopped till here.
Okay. Let's discuss this question. So we have to name the following halides and classify them as allyl, benzyl, vinyl, or aryl type of halide. Okay, so start this question. Let's solve this. Okay, first one. Let's draw the structure first. First, try to draw the structure. First one. So it's your CH3, right? The CH3, then here CH, then CH again, and okay. To the CH, there is a two substitution, CH3 and CH3, and to this carbon, there is a chlorine group, and here the methyl group. Okay, so first structure. This is the first structure. Now, just try to name this halide, okay, and just classify them as alkyl, and also mention the degree, okay, whether it's a primary, secondary, or tertiary. Similarly, you can write down for the second one also, for the structure first. So it's a CH3, then your CH2, then your CH. And here the CH3 group is there. And here C2H. Okay, one carbon and two carbon, so C2H5. और आप इसे ऐसे भी शो कर सकते हो CH3, right? आपको जैसे इजी लगता है you can draw the structure. CH3, CH2, CH, CH. Here the chlorine group, and here C2H5, and here CH3. Yeah. Try to name the structure and also classify them and write out, mention the degree also. Primary, secondary, tertiary. First, try to find the longest chain, which is known as a parent chain. Okay, then assign the number. Yes, Aneesha.
Yes, ma'am.
Okay, so let's write on the name, IUPAC name of the first one. Okay, so see, first you have to check which is the longest chain. So 1, 2, 3, 4, 4 carbon chain. This one is the longest chain. Okay, now try to assign the number in that order, in such a way so that the substituent or the functional group will get the lowest number, right? So you will start the numbering from the right side. 1, 2, 3, and 4. Right. Now what is the name? So you can see on the second carbon there is a substitution which is chlorine group is there, and on the third carbon there is a methyl group. Right. यहाँ पे क्या है? Only one carbon alkyl group is there, so it's a methyl. So what will be the name? So 2-chloro, and you will arrange the name in according to the alphabetical order. Right. So according to the alphabetical order, so chlorine C comes first, then M. Right. So you will write 2-chloro, 3-methyl, and how many carbon is there? 4. So it's butane. Right. And which type of, you can see, this is a secondary alkyl halide. Alkyl halide. Right. You can see halogen group is attached to this carbon, and this carbon is further attached to two groups. So it is your secondary alkyl halide. Clear, Aneesha?
Yes, ma'am. Ma'am, can you show me in the other form, like how you wrote for question 2? The
Yeah.
structure.
You can see the second example also. You
Yes,
can
ma'am.
see the second example also. See this example. First one, you can also draw the structure. See here, this is your CH3, right? आप किसी side से भी, suppose this is your the name, right? You can also draw the structure. You can start the numbering from here. So this is your CH3, now CH2, right? Now CH, and in the bracket, it's just represent the substitution. To which carbon is substituted? किस carbon से ये attached है? So the carbon which is prefix, right? इससे जो पहले carbon which is before this carbon, this substitution, this bracket. So it tells the substitution. Okay, कि this carbon, this CH3 group is attached to this carbon. Okay, so this is CH. right? And this CH3 group is attached here to this carbon. Next carbon, draw this. Now this carbon, this C2H5, which is in bracket, it is attached to this carbon. So you can write C2H5 and this chlorine. After that, this chlorine. Okay, so now first thing we have done the structure. Okay, we have drawn the structure. Now, what we are supposed to do for the IUPAC nomenclature, always first try to find the longest chain, longest carbon chain. The longest carbon chain is the parent chain. Okay, parent chain क्या होगा? The longest carbon chain. So you can see two carbon is there, right? Two,
Yes.
three, and you can also write down. इसे आप ऐसे भी लिख सकते हो, just like open करके CH2, CH3, CH2, CH3. Again the same thing, right? C2H5. You can see two carbon and five hydrogen is there, right? So instead of C2H5, you can also write CH2, CH3. It's same. Now let's find the parent chain first. So 1, 2, 3, 4, 5, 6. Okay, this is the longest chain, the 6 carbon chain. See this one. Clear?
Yes, ma'am.
Now see, if we start the numbering from the this side. 1, 2, 3, 4, 5, 6. Suppose. So where the substitution came? So on the third carbon, third पे क्या है? आपका chlorine है, chloro, and on the fourth position. And on the fourth position there is a methyl group, right? 3, 4. Right. On the third position there is a substitution which is chlorine group is attached, and on the fourth carbon there is a methyl group 3, 4. But when we start the numbering from this side, from the left side, so 1, 2, 3, 4, 5, 6. Again the substitution किस पे आया? 3 and 4. So it's not compulsory कि आप right side से ही करो. अब you can write down the naming, start the naming from the left side also. In both the cases, the substitution came to the third and fourth carbon. Okay, on the third and fourth carbon, there is a substitution from both the sides. Now, what will be the name for this? Try to name this. Third, on the third position, there is a chlorine group, and on the fourth position, there is a methyl group, right? And we
Yes, ma'am.
have to name according to the alphabetic order. Okay, and alphabetically, the chlorine comes first, then methyl. So we can write in the third carbon, there is a methyl group, sorry, chlorine group. So 3 chloro, 4 methyl, and how many carbon chain? 6 carbon chain. So for 6, we use X. Okay, and there is a single substitution, right? It means alkane is there. यहाँ पे double bond नहीं देख रहे हो आप. Okay, so it's a hexane, alkane. Hexane. Clear?
Yes, ma'am.
Now tell me which type of alkyl halide it is. Which type of alkyl halide it is? It's very simple, Aneesha. See this halogen group. To check which type of alkyl halide, see first see the halogen group. Halogen group is attached to this carbon, right? To this
Yes.
carbon, right? And this carbon, and what is this? This carbon is sp3 hybridized. sp3 hybridized, right? So it is
Yes.
known as alkyl. First one, alkyl halide. When the halogen group is attached to directly to the sp3 hybridized carbon, and further भी आप क्या देख रहे हो? Further when you move on to the next carbon, again this is your sp3 hybridized, right? So this is your alkyl halide. This is your alkyl halide. Now what is the degree of this alkyl halide? Tell me. Primary, secondary, or tertiary? Very simple. See this carbon. The chlorine is attached to this carbon, right? And this carbon is connected to, is attached to how many groups? How many groups? इस कार्बन से और कितने ग्रुप्स अटैच्ड है? See, two groups, right?
Two.
This
Yes.
CH2 and this CH group. So this is your secondary. This is your secondary alkyl halide. Is it clear now, Aneesha?
Yes, ma'am.
Okay, is it clear? It's clear, I think. So do the third and fourth. Do the third and fourth question. First, try to draw the structure. Okay, जैसे मैंने बताया step by step. After that, try to write down the IUPAC name, and after that, just classify them. Classify them as alkyl, vinyl, etc. Very simple. Just do the step by step. Do the question step by step. Done, Anisa. Third one.
Yes, ma'am.
Okay, tell me the answer. What will be the name of this?
1 iodo
Hmm.
3,3 dimethyl pentane.
Dimethyl pentane. Okay, let's see. आपने correct बताया या नहीं? Okay, so it's CH3, okay, CH2, then carbon, and on the carbon there is a substitution, two substitutions, CH3 whole twice, right? CH3 and CH3, then CH2 and iodine. Okay, so that's the structure. Now see, we have, this is your parent chain obviously, four carbon chain, this is your parent chain. Now we will start the numbering from the right side, okay, because the substitution will be on the first. Iodine will get the least number, right? Will get the least number, and same as for the methyl one, 1, 2, 3, and 4. Now what will be the name? See, so it's 1 iodo, so it's 2, 2, not 3, 3, Anisa. 2, comma 2 dimethyl. dimethyl, and there is a 4 carbon. It's not a 5 carbon, bache. See, CH3 whole twice. CH3 whole twice means on this carbon, there is a 2 substitution. 2 methyl group is attached to this carbon, right? So this is your 2 methyl group, and how many carbon chain is there? 1, 2, 3, 4. Only 4 carbon chain is there. So we will use butane, not pentane, bache. So it's butane. 1 iodo, 2, 2, 2, 2 dimethyl butane. Yeah, just correct it. On which type of alkyl halide it is? It's an alkyl halide, we know that because iodine is attached to sp3 hybridized carbon, right? So it's an alkyl halide. But what is the degree of alkyl halide? Tell me. Yes, what is the degree of alkyl halide, Aneesha?
Ma'am, primary.
Yeah, very good. It's primary. It's primary. Okay, fourth one. Have you done the fourth one?
No, ma'am.
Okay, do that. First, draw the structure. It's very simple. The bracket part that tells us about that represents the substitution. Okay, on the before carbon. तो पहले जो carbon है bracket से so the chlorine is attached to this carbon. Similarly, to this carbon has 2 methyl. Okay, methyl group, 2 methyl group is attached to this carbon, this CH. First, try to draw the structure. With CH3, right? CH3, then CH, and here there is a double bond, carbon, and on this carbon there is a chlorine group, CH2 again, CH, then CH3, and here again CH. Okay, so see, this is the structure. Now, how to number? Either you can assign the number either from the left side or the right side, but you have to decide in such a way that the substitution and the double bond, okay, means the substitution, functional group, and the double bond will get the least number. So when you start the numbering from here, so it will get 2, 4, right? 1, 2, 3, 4, right? So you will get 2 and 4. But here it will get 2, 3, and your fifth carbon. On the fifth carbon, there is a double bond. So you will start the numbering from here 1, 2, 3, 4, and 5. And what is the parent chain? So this is the parent chain. Okay, now try to name this. And yeah, in this case, you have to represent or you have to write down the position of this double bond also. Yeah, what will be the name? So it will be 3 chloro, 5 methyl. What is the number of carbon is 6. So it's hexane. Now you can't write ane, hexane. Okay, because all are not the singly bonded carbon. Here you can see there is a double bond between second carbon and the third carbon. Right? So there is a double bond. So you have to write down the position of the double bond. Double bond kahan pe? So after hex, you will write the 2. Okay, then E. So 3 chloro 5 methyl hex 2E. That's the name of this structure. Clear, Aneesha?
Yes, ma'am.
Now tell me which type of halide it is. Which type of halide?
Is it vinylic halide?
Yeah, very good. Yeah, very good. It's a vinylic halide. Vinyl halide. Yeah, so chlorine group, chlorine is attached to directly sp2 hybridized carbon. It's a vinyl halide. Okay, the fifth question is very important. See, fifth is para chloro C6H4 3H2CH CH3 whole twice. Now see this C6H4 C6H4 ये क्या show करता है? This basically shows the benzene ring, right? C6H4 basically shows the benzene
Benzene.
ring. Draw the benzene ring first. Now on the para position C6H4 and here to this carbon, suppose this is your CH2 attached. CH2 CH, and on the CH there is a two substitution CH3 CH3. So you can write CH3 and CH3 just like this. Now see this term. This is parachloro. Okay, so corresponding to this carbon, suppose this carbon पे attached. Suppose this is the first carbon, right? So corresponding to this carbon, this is your para. This is your ortho position. Ortho, इसे हम क्या कहते हैं? Ortho position.
Or
So
to
is your meta,
not
right? And this is your para position. This is your para position. Okay, similarly, this is your ortho, meta, and para. Ortho,
yes.
meta, para. Yeah. So you have to attach the chlorine to the para position. So यहाँ पे आप attach करोगे. Clear? So that's the structure of this. Sorry. Okay. Now say what will be the name? How to name this? Okay. For again, I'm drawing this chlorine over here. This is CH2, and to CH2 there is a CH group, and to this CH group there is a CH3 and CH3. Okay, same structure. It is the same structure. This CH2 is attached to the CH. Then this CH has two substitutions, CH3 and CH3. Two methyl groups are attached to this carbon. Okay, now how to name this? So this is a chlorine group. So we have to name number in such a order that the chlorine, okay, that the substitution or the function group will get the least number. So आप यहाँ से start करोगे. 1, 2, 3, 4. 1, 2, 3, 4. This is your 5 and 6. Okay, so how to name one chloro. Now on the fourth position, you can say there is a substitution. ये पूरा क्या है? This is a group which is attached to the fourth carbon of the benzene ring. So you will write 4, comma, 4, then bracket. You will write down the bracket. And in the bracket, you will name this. You will name this. So suppose this is your fourth. Okay, so you can name this carbon as 1 dash. Okay, 2 dash and 3 dash. Okay, so this is your, you can see this is your secondary chain. यहाँ पे क्या है आपका secondary chain which is attached to the C4, the carbon, fourth carbon of the benzene ring. So this is the secondary chain. Okay, so this is a secondary chain. So आप secondary chain में this is your parent. This is your parent chain. So primary 1 degree, so not 1 degree, 1 dash, 2 dash and 3 dash. Suppose इसका हमने numbering दे दिया 1 dash, 2 dash and 3 dash. Now you will write on the second position. Okay, 4, comma. Now bracket mein you are naming this group, this whole branching. So on the second position of this carbon, see on the 2 dash position, this carbon, there is a methyl group. So you will write 2 methyl and 3. For 3 carbon chain, we named it as a propyl. Okay, propyl, because this whole ring, this whole group, it is acting like a substituent That's why we will write I, propyl, not a propane. Okay, in word we use in a parent chain. Okay, so 1 chloro 4 dash 2 comma 2 dash methyl propyl. So this whole group is known as your 2 methyl 2 methyl propyl. On the 2 position, 2 dash position, there you can see the methyl group, right? And this is your propyl. And this whole 2 methyl propyl is attached to fourth carbon. That's why हमने यहाँ पे 4 comma and we just write this name in the bracket because this again is a substitution. And what is the parent name? What is the parent name of the whole molecule? Benzene, right? So you will write at last benzene. Okay, so that's the name of the IUPAC name of this compound. 1 chloro 4 dash 2 methyl propyl benzene. Is it clear, Aneesha?
Yes, ma'am.
Just now tell me which type of halide it is. Very simple. Which type of halide it is? Just see the halogen group is directly attached to the benzene ring. Yeah,
Aryl halide.
yeah, it's a aryl halide. Okay, is it clear now?
Yes, ma'am.
So that's how we just write down the IUPAC name of this type of compound. Okay, next. Yeah, actually we have done this nomenclature. Right, तो हमने examples के through we have discussed this nomenclature. But no problem. Let's discuss it once again. Nomenclature. So in common because common system is not very important. The IUPAC nomenclature is very important. The question can come from that part. Okay. And in the boards 1 mark questions where they can ask write on the IUPAC nomenclature of this. Okay, so that's important. In common system, how to write down the name of the compound? So basically, we have to add word halide. Last may we just write down the halide as a suffix. Okay, to the name of the corresponding alkyl group. Okay, so basically we just write down in the manner alkyl halide. Okay, so in common system, we write down alkyl halide. So that's it. Alkyl halide is in a common system. First, we just write down the alkyl word or the alkyl word, and after that, we just use the halide word for the halogen group, which is attached to the carbon of the alkyl. So that's in common system. And in common system, we just write down the prefix. We use the prefix normal for normal, just like a straight chain. Suppose there is a straight chain or aliphatic chain, तो उसके लिए हम क्या use करते हैं? We just write down the prefix n. Okay, so n represents that is a straight chain, normal chain. There is no branching. Okay, and for iso type of a structure, secondary, for tertiary type of a structure, we just write prefix as iso, sec, and third. Okay, so we just use these prefix in the common name when we write the common name. And but in IUPAC nomenclature, alkyl halides are named as halo substituted hydrocarbon. Okay, halo substituted. First, you just write down the halo word, just like we have done this. We have written over here 1 chloro. Okay, 1 chloro. So first we have written the halo group, halo word. Okay, for the given halogen. After that, we have write down the alkane word. Okay, so name are written by prefixing the word halo. Okay, it's in the IUPAC nomenclature, but in the common system, we just write down the alkyl halide in this format. Suppose, first example, see this question. Bromine is attached to this carbon, right? And this is a 3-carbon chain. Okay, so what is the common name of this? Common name of this will be, you can see there is a no branching you can see over here, right? The straight chain आप देख रहे हो यहाँ पे. So for the straight chain, for the normal chain, what we write? We use prefix N, right? N, and for 3 carbon chain, we just write propyl, and for the bromine group, we use bromide. Clear, Aneesha?
Yes, ma'am.
And what will be the IUPAC name?
1 bromo propane.
Good. Second one, write down the common name and IUPAC name. This is the iso type of a structure, right? Chlorine is attached to. आप इस टाइप का कभी भी देखो तो this type of a structure is iso type of a structure. इसके लिए हम क्या प्रीफिक्स लगाएंगे?
Iso
Iso. Iso, and when
propyl
we write down yeah, isopropyl,
chloride.
yeah. Good. And what's the common IUPAC name?
2 chloropropane.
Third one, common name.
Uh,
Yeah, again, this is your
is,
iso. Yeah.
iso
Hmm.
butyl
Yeah, good. Butyl.
methane.
Why methane? Which is chloride. Halide, we just write down in the suffix. Isobutyl. Butyl for the whole carbon. 1, 2, 3 carbon. Right? Isobutyl, ये सारे groups का इसका क्या नाम हो गया? It's isobutyl. And after that,
Okay.
there is a chlorine group. So we will write chloride. IUPAC name?
1 chloro 2 methyl
Yeah.
propane.
Yeah. Yeah. See the next. Which one of the following halide contain this type of bond? Which option will be correct?
Vinyl halide.
Yeah, good. It's phenyl halide. Yeah, one more thing. This is a previous year question. ये आपके बोर्ड में पूछा गया है. Try to name this compound. You have to write down the IUPAC name.
Ma'am,
Yes.
2 bromo,
Yeah, just a second. That's two.
bromo,
Are you sure? Two bromo. Okay, yes. Two bromo, yes.
2 methyl, pent 4 in. I'm not sure. Ma'am.
See, see here. See, this is the parent chain, right?
Yes, ma'am.
First, you have started the numbering from the right side, I think. So one,
Yes,
two,
ma'am.
three, 4, 5. Now, when you start the numbering from the right side, you will get 2, comma 2, comma 3, right? There is a 2 substitution on the second carbon, bromine and methyl. And third पे आपका क्या है? Double bond. Now, when you start the numbering from the this side, so it will give 1, 2, 3, 4, right? So it will give you 2, comma, right? 2, comma 4, comma 4. 2, comma 4, comma 4. Now, you have to give the double bond the smallest number. Okay, आपको double bond को ज़्यादा preference देनी है. You have to give the double preference to the double bond. आपको ज़्यादा preference किसे देनी है? Double bond को. So you should start the numbering from this side, not this side. Yeah,
Okay, ma'am. So,
yeah. So what will be the name now? So it will be 4, comma
4,
4 bromo, 4 methyl, pent 2 ene. 4 bromo, 4 methyl, pent, and is on
methyl,
the second there is a ene. Yeah, so that's the correct name.
and to. Yes, ma'am.
Yeah, perfect. Now the nature of CX bond, because we are talking about the haloalkane and haloarenes bond. Okay, so in halo means the bond between the carbon means the carbon of the alkyl group or the carbon of the aryl. So what is the nature of this bond? What is the nature of this CX bond? So you can see over here, there is a large electronegativity difference between the halogen group and the carbon, right? So carbon and between the halogen group, there is a large electronegativity difference because we know that halogens are the most electronegative elements, right? They are the most electronegative elements. So suppose what is halogens? We are talking about the fluorine, chlorine, bromine, or either iodine, right? So whenever this bond will break, so due to the high electronegativity of the halogen atom, this halogen atom has a tendency to pull all the electron towards itself. वो अपनी तरफ सारे electrons pull कर लेता है. Why? Because it has a high electronegativity, right? So halogen is more electronegative than the carbon. So when this bond will break, the hydrogen will acquire partial negative charge. Okay, always halogen पे क्या आएगा? Negative charge, and the carbon, this is a electropositive. Okay, when you compare these two, carbon and halogen, so this is less electronegative, or you can say electropositive, so it will acquire partial. Yeah, so due to greater electronegativity of the halogen atom in carbon and X bond, CX bond, acquires partial negative charge, and the carbon atom, it acquires partial positive charge. Just remember this, very important. Okay, write down.
Done.
Okay, now the next topic is isomers of haloalkene. Okay, so first, so what do you mean by isomers? So isomers are uh, those structures, you can say those structures which have same molecular formula but different structure formula, right? So basically, there are two types of haloalkenes have two types of isomers. First is chain isomers. Chain isomers are those isomers which are differs in parent chain length. Okay, the number of carbon will be the same, the molecular formula will be the same, but the difference will be there in the parent chain length. The chain will be shorter. When you compare the chain of the isomer to the parent chain, so the parent chain length is more than that of the isomer. Okay, so chain isomers are those isomers which are differs in parent chain length. That's simple. But positional isomers are those isomers which differs in the position of halogen atom. Okay, the position of the halogen atoms वो different होगा, but the molecular formula will be the same. Okay, so that there are two types of isomers which exist for the haloalkane. Chain isomers, जहाँ पे क्या होगा? Chain isomers में they differ in the parent chain length. Chain length will be different from that of parent, but the positional isomers are those isomers in which the halogen atom की position change होती होगी. Okay, halogen atom position is different. Clear, Aneesha?
Yes.
Okay, let's understand this by this question. This is your NCRT question. It is given in the NCRT. So, question is draw the structures of all the 8 structural isomers that have the molecular formula C5H11Br. Okay, so this is the molecular formula C5H11 and Br. Okay, and we have to draw all the structures, all the 8 structural isomers of this, right? And also we have to name each isomer according to the IUPAC system. Okay, and we have to classify them as primary, secondary, or tertiary bromide. Okay, that's very simple, very interesting question. So let's do that. First, try to draw all the structures. First, we will start with the normal chain. Okay, the simplest straight chain से we will start. So C5H11, number of carbon will be 1. ठीक है? There is a 1, 2, 3, 4, 5. Okay, so this is a 5 carbon chain. See, one, all the corners, each corners represents carbon. Okay, 1, 2, 3, 4, 5. 5 carbon chain, and there is a bromine group. Bromine group. Okay, so that's the structure of the C5H11Br. Is it clear, Aneesha?
Yes, ma'am.
Yeah, so this is their normal N-bromopentane. Okay, 5 carbon chain it is, so it's pentane. So N-bromopentane. So you can write down the name of this. It's 1, you can see one position, 1 carbon, second carbon, third carbon, 4 carbon, and 5 carbon. So on the first position, there is a bromine group. So it's the name of this will be 1-bromopentane. Now, what we are supposed to do, we have pentane, right? 5 carbon chain. Now shift this bromine group. The bromine is on the first carbon, right? Now we have to shift one by one this bromine group to each and every carbon. Okay, so this in first isomer is 1-bromopentane. Now let's shift this bromine to the second position. So क्या हो जाएगा आपका? The chain will be same, 5-membered ring, 5-member chain, 1, 2, 3, 4, 5. Now instead of first carbon, the bromine is attached to the second carbon, right? So this is another isomeric form. You can see the carbon molecular formula is same, but the structure is different, or the position of halogen is different. Okay, first में क्या था? The bromine was attached to the first carbon, but in the second, the bromine is attached to the second carbon. Okay, but the formula is same, C5H11Br. You can count the hydrogen, carbon, and so on. And what will be the name of this? So again, this is your 2-bromo
Pentane.
pentane. Yeah. Okay, let's shift this bromine here, right, on the third carbon. So what will be the 1, 2, 3, 4, 5? And here, when you shift this bromine, so you will get this. Yeah. So what will be this? This is 3-bromo.
Pentane.
Yeah, good. Now tell me, Aneesha, if I attach this bromine to the fourth position, okay, अगर मैं fourth position पे 1, 2, 3, 4, and if I attach this bromine fourth position, now try to name this. Try to name this. So you will not start the numbering from here. You will start the
No,
numbering
no.
from here. So again, this
Yes.
is your 2-bromo, 2-bromo
Um,
pentane. So this is not the unique one. 2-bromo pentane तो हमने बना रखा है. It's already written here, right? We already have drawn. So only 3 isomeric form is possible for the pentane. Now, if the parent chain length is pentane, 5-carbon chain, then only 3 isomeric form exist. Okay, because अगर हम bromine को यहाँ पे attach करेंगे, you will get the same 2-bromopentane. Okay, and isomers are unique structure. Okay, not the repeating one. Okay, so isomers are unique structures. So 3. And now what we are supposed to do for pentane, we have done 3 isomeric. Now we can also do one thing. We can short the parent chain structure. आप chain isomers draw करो. Okay, so chain isomers, what we are supposed to do? Just reduce the parent chain. So this was pentane. So आप अब क्या करोगे? You will draw the butane. Okay, just draw the butane first. One, two, 1, 2, 3, 4. Okay, 4-carbon chain. 1, 2, 3, 4. It's butane. Now one carbon is again left. One carbon and one bromine. Okay, we have one carbon and one bromine. So it's a butane. So you can add the bromine over here to this carbon. Okay, you can attach the bromine to this carbon. Now, what about one carbon? One CH3. Okay, we have one CH3 also. So we can add substitution over here. In the first carbon, there is a bromine group. So you can attach the CH3 on the second carbon. You can attach the bromine to the second carbon. So this is again the isomeric form. Okay, you can count the carbon. One carbon, two, three, four, and this methyl group carbon is 5, right? And this bromine group. So the molecular formula again is same, but the structure is different, right? Now
yes.
again you can do one more thing. Now you can shift this bromine group. This is the first carbon. This is second. This is third, and this is fourth. आप this methyl group कैसे act कर रहा है? This is acting just like a branching substituent की तरह act कर रहा है. This is not a part of the parent chain. This is not a part of the main chain, right? So this is acting like a substituent. Now just shift this bromine again. We are moving. We are supposed to move this bromine on the second carbon position, on the third carbon position. So you will get different isomeric form. Okay, let's do that. So 1, 2, 4 carbon chain था. यहाँ पे क्या था? There was a methyl group. Now this bromine group, just attach this bromine group again here. So you will get this isomer. Next 1, 2, 3, 4, 4 carbon. This was a methyl group. And when you attach this bromine to the third carbon, so you will get this. Again, the unique structure. Yeah. Now try to name this. And one more thing you can do. Uh, yeah. If you can, yeah, same thing. You can attach the bromine group to the fourth carbon. You will get the another thing. Let's see. 1, 2, 3, 4. This is a methyl group. Now, when you shift this bromine to the fourth carbon, you will get another isomeric form, not the same as first. Okay, if you write down the name of the first, see this one. What will be the name of this? It's 2
One,
methyl. Yeah, 1 bromo, 2 methyl, 1 bromo,
two
2,
methyl
or it's butane.
butane.
Okay, and this one, try to name this.
Hmm. Uh, one
Yeah,
bromo.
yeah,
um,
2 and 3, right?
One, two, yeah. Three methyl
Hmm.
butane.
Yeah. So you can see the difference. Yeah. So here on the first, the substitution, the methyl group is attached to the second carbon, but here the methyl group is attached to the third carbon. Yeah. So both isomeric form exist. They are not the same. Both are different, right?
Yes.
Okay. Try to name this. This is second position. So 2 bromo,
Two
right?
bromo
2 methyl
butane.
and it's butane. Yeah. This one, we will start the numbering from there. Again,
Two
2
bromo.
bromo. Hmm.
Three methyl
Hmm.
butane.
Yeah, good. Now see how many isomeric form we have. Draw 1, 2, 3, 3, 3, 6, 7. Okay, but 8 isomeric form exist because in the question they just give you draw the structures of all the 8 structural isomers. Now one more thing we can do. Now we are supposed to, yeah, it's butane. Now we can reduce the chain, parent chain की length को short कर दो. Right. Now it was butane. First we have draw all the isomeric form of pentane, then butane, then we can draw it for the propane. Right. Means only 1, 2, 3 carbon chain. 3 carbon chain. Now we have 3 carbon chain. Now we have 2 carbon and 1 bromine group. Right. So
Yes,
how
ma'am.
we can
Yes.
attach this 2 carbon, and so we can use this 2 carbon as a branching. We can use this as a substitute. So just add it. We can substitute it on the second carbon, right? And on the first carbon, we can substitute the bromine, right? So this is the first carbon, this is the second carbon. So on the second carbon, we have used this 2 carbon, which is the remaining 2 carbon chain as a substitution, right? So this is your another isomeric form. Okay, आप ऐसे भी ड्रॉ कर सकते हो CH3, C, CH3, CH3 here, this is CH2, and this is your here. Okay, that's the same structure. Yeah, so one, this is your 3 carbon chain, which is your propane. This is your propane. Now, the bromine is attached to the first carbon, so it's 1 bromo. Right, on the second carbon, there is a 2 methyl group, 2 comma 2 dimethyl. This dimethyl propane. Is it clear, Aneesha?
Yes, ma'am.
Any doubt? Now you can draw each and every structural isomers. अब कोई भी questions आए like if they just change the molecular formula, they will give you some molecular formula and they will ask you draw this all the structural isomers and write down the IUPAC name, and also yeah, one more thing, just classify each and every isomer as primary, secondary, or tertiary. Tell me the first one.
Primary.
Huh? Second one.
Uh, Secondary.
Yeah, very good. Third one.
Mm, Secondary.
Hmm. This one.
Primary.
Uh, yeah, this one.
Oh, primary.
Are you sure? You have to check this bromine group. Bromine group is attached to this carbon, right? And this carbon
Yes.
is attached how many groups? One, two, and three groups. So it's tertiary, bache. Yeah,
Okay.
this one.
Secondary.
Good. This one.
Primary.
Good. This one. Last one.
Primary.
Yeah, it's fine. Okay, now you can do this type of question. Next topic is methods of preparation.
You copied all the questions previous?
Yeah, so the methods of preparation of haloalkenes. So how we can prepare the haloalkenes? So basically we can prepare the haloalkenes by different methods. There are many methods for the preparation of haloalkenes. Okay, so first method is from the alcohols. We can use different reagents and we can prepare the haloalkenes from the alcohol. Okay, so first is write down first heading method of preparation of haloalkenes, and in this write down from alcohols. From alcohols, how we can prepare the haloalkenes. That's very important and very simple. First is using phosphorus-based reagents. Using phosphorus-based reagents. So when you treat the alcohol with different phosphorus-based reagent, so you will get the corresponding haloalkene. But suppose when this ROH, this is your alcohol ROH, when you treat it with PCl3, okay, PCl3. So in this process, you will get this OH. Basically, OH is replaced by the chlorine group, right? The chlorine group, and you will get the corresponding haloalkene. Yeah. So in this case, chloroalkane, or you can write alkyl chloride. You will get the product alkyl chloride, and the byproduct you will get is H3PO3. H3PO3. Clear? Very simple. You have to just replace the OH group of the alcohol by the chlorine group, and you will get the corresponding haloalkene, halide you can say. Similarly, when you use a Br3 as a reagent, Br3 as a reagent, what will be the product? So just remove this OH group. Okay, just replace this OH group by this bromine group, and you will get the halobromide, alkyl bromide you can say. Similarly, third one, when you use a red phosphorus with X2, X2 could be your either your bromine or iodine. X2 आप क्या लिख सकते हो? Either bromine or iodine. And this process is basically for the formation of alkyl halide. And alkyl halide maybe there is a bromide, okay, alkyl bromide and iodide, because we are taking reagent as a Br2 or I2. Okay, आप Br2 ले सकते हो or either I2 in the presence of red phosphorus. So when you treat the alcohol to the red phosphorus plus your X2, X2 could be your Br2 or I2, so you will get corresponding alkyl halide. Sorry. Similarly, the next is your ROH. When you treat the ROH, means alcohol with a PCl5, so again this OH will be replaced by this chlorine, and you will get RCl. Yeah, RCl, that's very important. So these are different reagents. When we use the different phosphorus based reagent, when you treat these reagents with the alcohol, so you will get the corresponding halide. That's the one method of preparation. Yes, Aneesha, have you any question?
No, ma'am.
Okay, see this. Yeah, see this example. This example. So first is your CH3 CH2OH. Okay, so here the alkyl group is, so as I told you, ROH, when you treat it with PCl3, so basically this OH group is removed. Okay, this is replaced by the chlorine group and you will get RCl. So here the alkyl group is CH3, CH2, okay, CH3, CH2 and OH. Okay, so when you treat it with PCl3, when the reagent is PCl3, what you are supposed to do, just replace this OH group with chlorine. You will get the product. Okay, so this will be your corresponding